Hello guys, welcome to Cambridge Guru. We are starting with the third topic of pure mathematics, that is trigonometry. This is the third unit. 2 units we have already completed. First was algebra, in which there were two topics. One was polynomials and second is modulus function. Both the videos have both the videos for both the topics have already been uploaded. Second unit, I think it was logarithm and exponential. So that has also been completed. Let us start today with trigonometry. I think in the AS level we have done basic trigonometric identities, which was sin square theta plus cos square theta is equal to 1. And what is sin theta? It is, the basic definition of sin theta, it is ratio of perpendicular and hypotenuse, right? This you already must have understood in your AS level classes. So here we will understood three more trigonometric ratios, which are nothing but the reciprocals of the three basic ratios that you have already learned in AS level. So let us start. These are called basically reciprocal trigonometric functions. Apart from three main trigonometric functions, sine, cosine and tangent, there are three more trigonometric functions which are commonly used. These are the reciprocals of main trigonometric functions. So we have a cosecant function cosec, which is nothing but a reciprocal of sine theta. Here it is shown. And then we have a secant. We say in short it is sec, which is the reciprocal of cos theta. And lastly we have cotangent. In short it is pronounced as cot theta, and which is defined as a reciprocal of tan theta. So cot theta is basically the ratio of cos and sine, as tan theta is the ratio of sine and cos. So we call these three new ratios as the reciprocal of three basic ratios, sine theta, cos theta and tan theta. These are the graphs of these three new basic functions. The red ones are that you have already understood in your AS level, right? Sin x like this, starting from 0, 180, 0 and 360, 0, and maximum and minimum value for sin theta and cos theta are plus 1 and minus 1, right? So these red ones are already known to you. These blue ones are new graphs, means the reciprocal graphs of sin theta, cos theta and tan theta respectively. So I will try to sketch the graph of cosec theta, and on the same line you may be able to draw or sketch the graph of other functions, means sec theta and cot theta. So let us quickly sketch the graph of cosec theta and let us understood how we can sketch this blue curve. This is my y-axis, suppose this is your x-axis, and basic angles that we take are, let us say, 0 degrees, and here we have pi by 2 means 90 degrees, this is 180 degrees, this is 270 degrees, and lastly we have 2 pi, which is 360 degrees. Okay, this is your positive x-axis, this is your y-axis, this is minus y-axis. Okay, all right. Now as we know that since cosec theta, in short I am writing this as CSC, this is nothing but reciprocal of sine theta. So first we will see the allowed values of theta, means for what values of theta this cosec is defined, or in other words we will look at the points where this cosec theta is not defined. Okay, so this cosec theta will not be defined wherever sine theta is 0, right? So sine theta is 0 at theta equal to 0, at theta equal to pi, 2 pi, 3 pi and so on. So for integer multiple of theta, sine theta will be 0. So in those, on those angles, on those values of theta, this cosec theta will be not defined. Not defined means it will approach either to plus infinity or it will approach to minus infinity, depending upon sine theta is positive or negative respectively. This is first case, or not case, but it is first thing that we have to note. Second thing that we have to note is we will look at the minimum and maximum value of cosec theta. as we are saying that cosec theta at some values of theta, it will approach to plus infinity and minus infinity. So maximum value that cosec theta can attain is plus infinity. Minimum value it can attain as minus infinity. But the important thing is that the graph of cosec theta will not lie between minus 1 and plus 1. Okay, between minus 1 and plus 1, the graph of cosec theta won't lie, because this denominator sin theta can be maximum plus 1 and minimum minus 1. Okay, had it been greater than 1, let us say sin theta hypothetically takes the value as 2, then only cosec theta will be 1 upon 2, means 0.5. Okay, and this is not possible that sin theta will attain a value which is greater than 1. Hence, cosec theta won't attain any value between plus 1 and minus 1. Okay, it will always be greater than 1 or it will always be less than minus 1. Okay, so let us mark the point on the y-axis as plus 1. This is 1 and this is minus 1. Okay, now at theta equal to 0, sin theta will be 0. Okay, so at theta equal to 0, cosec theta will approach to a very big value, or you can say not defined, means the value which is approaching to plus infinity. Okay, since theta is positive, sin theta is positive, and theta lies between 0 to 90 degree, so sin theta will be positive. That means cosec theta will approach to plus infinity. Okay, at theta equal to 0, right? So my graph will start from here, right, and it will start decreasing, right, and it will attain a value of plus 1. Why? Because sin theta can attain maximum value of plus 1 at theta equal to pi by 2. So at theta equal to pi by 2, this cosec theta will be 1. Okay, so graph will decrease like this. At theta equal to pi by 2, it will achieve a value which is plus 1, and after pi by 2, since angle is again going to increase, this sin theta is again going to decrease, so cosec theta is again going to increase, and at theta equal to pi, sin theta will again be 0, plus 0 you can say, so cosec theta will approach to plus infinity again. So cosec theta's graph will again increase to plus infinity like this, and it will never intersect the curve which is x equal to pi and x equal to 0. So I can say that these x equal to 0, x equal to pi, these are vertical asymptotes. Okay, these are vertical asymptotes for cosec theta. Okay, let us take the angles which are in now third and fourth quadrant, means theta is greater than pi. So if theta is greater than pi, angle is in third quadrant, so sin theta will be negative, hence cosec theta will be negative, right? And if you take a value which is very closer to pi but in the third quadrant, it is, let us say, greater than, which is approaching to pi but from right. Okay, from right, in the sense that theta is slightly greater than pi, but it is approaching to pi from right. Okay, in the limit sense we say this. So this sin theta which is closer to pi but slightly greater than pi, it will be negative 0. Okay, negative 0 means it will, cosec theta will be 1 upon a value which is very small, but it is approaching to 0 from negative side, right? So cosec theta will be approaching to minus infinity, not plus infinity, because this whole value is now negative. Okay, so graph of cosec theta after theta equal to pi will start from minus infinity like this. At theta equal to 3 pi by 2, sin 3 pi by 2 is minus 1, so cosec theta will be minus 1. Okay, so it will decrease, and again after 3 pi by 2 it will increase and approach to minus infinity here, because here in the third and fourth quadrant sin theta is negative, so cosec theta will always remain negative. Okay, so from 0 to 2 pi, this is the graph for cosec theta, right? On the same line you can sketch the curve for sec theta and cot theta by knowing some values of trigonometric functions, cos theta and tan theta, right? And applying the rule that what will happen if these cos theta and tan theta are in denominator. Okay, where this sec theta will be defined, where the cot theta will be defined, Okay. In the negative direction also, you can sketch the curve that, let us say, this is your minus pi by 2, this is minus pi, minus 3 pi by 2 and minus 2 pi. So this minus pi is again will be your vertical asymptote, right? In the negative means this is your fourth quadrant. If you are measuring angle clockwise, it means negative angle means you are in the fourth quadrant. Okay, so in the fourth quadrant again, when theta is approaching to 0 but from the fourth quadrant towards 0 like this, so again the graph will approach to minus infinity and it will, start decreasing, attain a value minus 1 at theta equal to minus pi by 2, because at theta equal to minus pi by 2, sine minus pi by 2 will be minus 1, so cosec theta will be minus 1 and it will again decrease to minus infinity like this. Okay, and these cycles you can draw. Okay, all these trigonometric functions, whether sine, cos, tan or their reciprocal functions cosec, sec and cot, all the 6 trigonometric functions are periodic in nature. Okay, are periodic in nature. Okay, so this 2 pi is again one vertical asymptote. Okay, likewise you can draw the graph for sec theta. This sec theta is nothing but 1 upon cos theta. Okay, so on using this red color you can see that, okay, instead of multiple of pi, in case of sec theta, odd multiple of pi by 2 will be your vertical asymptotes. Okay, so it will be like this. Here in this case of pi by 2, 3 pi by 2, all these are vertical asymptotes. Okay, like this. Right, so this is the graph for sec theta, red one. Similarly, you can sketch the graph for cot theta. Now let us take some example on what kind of question will come under the whatever is in your syllabus. So let us see. We have to find the values of theta in the interval 0 to 360 degrees, for which sec squared theta is equal to 4 plus 2 tan theta. You might have learned this one basic identity, which is sin squared theta plus cos squared theta is equal to 1. Okay, but in this case, as we have now involved two new functions, three new trigonometric ratios, sec, cosec and cot, so there must be some other identities also which involve these three new trigonometric ratios. So we can derive two new identities from your basic identity, sin squared theta plus cos squared theta equal to 1. So first identity I am deriving by dividing this identity with, let us say, cos squared theta. So let us divide this with cos squared theta. In short, I am writing this as c square. So sin square upon cos square, I can write this as tan square theta. Cos square theta upon cos square theta, it is 1, and 1 upon cos square theta is sec square theta that we have just learned, because 1 upon cos is sec. So this is our second identity that we have to remember. If there is some equation which involves sec square and tan square, or sec square and tan, we can replace sec square with tan square. Okay, like this, sec square is tan square theta plus 1. And similarly, if I divide this original equation sin square theta plus cos square theta with sin square theta, you will get a third identity, which is 1 plus cot square theta is equal to sec cosec square theta. Okay, so there is no need to convert this this question there is no need to convert back into sin square and cos square. If you remember this identity, that I can replace this sec square theta with 1 plus tan square theta, then the whole equation will be in single trigonometric function, which is only tan theta, which can be solved using your quadratic formulas or using some calculators. Okay, these type of question we have done in our AS level, but in those questions there was only tan theta or sin theta or cos theta. These new functions were not there. Okay, but how to solve these trigonometric equations? The method will remain same. It is just some new identities have been introduced. Fine. So now let us solve this question, that as I have said just now, that this sec square theta will be replaced by 1 plus tan square theta. So let us quickly replace this with 1 plus tan square theta, that is your LHS. This is 4 plus 2 tan theta. Okay. So tan square theta minus 2 tan theta, this is 1 minus 4 is 3 equal to 0. So tan square theta minus 2 tan theta minus 3, I can factorize this. This is tan square theta minus 3 tan theta plus tan theta minus 3 equal to 0. This is tan theta minus 3 plus 1 tan theta minus 3 equal to 0. Okay. So I have tan theta plus 1 and tan theta minus 3 equal to 0. So I have two equations, which is tan theta equal to 3 or tan theta is equal to minus 1, right? For these two equations, and remember, I can take theta both in the positive quadrants and in the negative quadrants. Negative quadrant means if tan theta remains negative in second and fourth quadrant, so those angles will also be introduced corresponding to each equations. Okay. So if I take tan theta equal to 3, I get theta as tan inverse 3. So your principal value of theta will be, let me quickly check this, tan inverse 3 is 71.56, right? This angle will be in the first quadrant, and again tan theta is remain positive in the third quadrant. So next angle will be, I can add 180 to this, which is 251.56. So two angles corresponding to tan inverse 3 are 71.56 and 251.56. Okay, this is for only tan theta equal to 3, and corresponding to tan theta equal to minus 1, your basic angle theta will be tan inverse 1 means 45 degrees, right? But here it is tan which is negative. So negative means in the second and fourth quadrant. So you will get theta as 180 minus 45 means 135, and then 360 minus 45, which is 315. Okay. So these four angles are the solution for the above trigonometric equation.